And our next speaker is going to be talking about the systematic assessment of damage to buildings due to groundwater lowering-induced subsidence by Korff.
Thank you. Just ja, okay. Alles goed zien. Yes. Okay, good afternoon. Yes, my name is Mandy Korff. It was just already mentioned foundations of buildings. Well, spot on, I would say. This presentation is about the damage to structures, buildings in the Netherlands on a national scale. It's actually a sort of a combination of the 2020 paper with the 2023 results that I added to it, but even some work that has been done since that I include. First, I start with a question for you. This is a non-representative selection of buildings from the Netherlands. One of them is the one I'm living in at the moment. I won't tell you which one. Just a sort of random selection. And if subsidence is happening in the Netherlands, we have heard Peter and lots of other people that we have subsidence in the Netherlands. Buildings are all over the place. So which of these buildings will be damaged by subsidence? Anybody tell me? Mine or the others? All? Maybe? Hopefully not. Okay, this is of course a question that's almost impossible to answer, and even probably it is possible to answer for maybe if we look at the buildings one by one and we look at the soil at that location and we look at the groundwater conditions in that specific location. So then we will be able to say something about those locations. But of course, these are just four and a few along the side, but we have 8 million buildings in the Netherlands. So if we want to have an idea of the damage that is going to happen to those buildings, we need to know a lot about those buildings, about their foundations. That's my specialty, but that's quite important if you want to assess the damage that results from it. So what kind of subsidence am I focusing on in this case? Because it's shallow subsidence and mainly related to groundwater, and droughts is a very important driver for that amount of subsidence. This is just a picture on the left is for Europe. It's at the moment. The Netherlands doesn't show up yet. We had a lot of rain in the winter. This is a March picture, but also in the summer we have this, but you can see all over Europe and also in Asia, and actually all over the world. This is becoming a problem. So the sort of source of subsidence that I'm looking at is groundwater related droughts. In summary, what's the risk that we are looking at is the cost of repair and the damage itself all the way on the right. And then in the middle is the building. Is it on shallow foundations or is it on piled foundations? And on initially, of course, is where all the problems come from, is the subsidence itself, and then the ones caused mainly by droughts. I have to be a bit more specific on the foundations because we have shallow foundations and piled foundations, but these are specific piled foundations because timber piles, we have quite a lot of them in the Netherlands, buildings on timber piles. And timber pile buildings are indirectly influenced by subsidence, mainly by groundwater lowering. So the piled buildings that are on concrete piles or even on steel piles sometimes, they don't suffer so much from the subsidence, but especially the timber piles and the shallow foundations suffer most. So what I'm going to show you today is about those types of foundations. And the whole aim of this study is to give you insight in which areas on a national scale for the Netherlands buildings are at risk. And we cannot wait for all the detailed models to be ready. It's very good work that's going on in the model chains and so on. But we also need, for policymakers to take measures, we also need an insight at this moment already. So for the two damage mechanisms I just mentioned, so the drawdown, that the groundwater lowering that has an effect on the degradation of timber piles, and the differential settlements that cause damage to the shallow foundations, those are the ones that are combined now in a model for the whole country of the Netherlands, and that there is a main request for that is shown in some newspapers, but we have seen many examples already about this topic, and you can, well, any newspaper almost at this moment, you can find those things. So what we did is set up a modular system, and it's not perfect, and it's a lot of things combined, but it has a systematic approach, and the systematic approach comes from the hazard, vulnerability, and exposure combination that together drives the risk. And then these two streams that you see is the stream for the timber piles at the top, from left to right. So first you need input on the hazard. In this case, it's the lower groundwater that is occurring due to droughts, climate change over the long run, so over a period of 50 years. Exposure is what do we find where, and vulnerability is how sensitive is it to damage. So you need all kinds of functions for that, and lots of people in this room know about different parts of this whole chain, and what we have done in this model is bringing it together. Also working together with economists to also give us an idea on the costs of the damage that are related. So not just the technical part of it. Going a little bit more in detail on these two approaches. First for the timber pile degradation. So it's really the degradation of the pile that causes the problems. We need already quite a lot of information for 8 million houses about which one is on timber piles, for example. So what is the probability that any given building in the Netherlands has a timber pile foundation? Now, that's one of the main things that is lacking in information at this moment. So a lot of data is gathered. We know the age of the building, we know the height of the building, we know how many people live there, we know their income, how much tax they pay, we know all that. But we don't know such a basic fact as what kind of foundation is under which structure. So with expert knowledge and assessments that have been locally done, we have made a complete picture of the Netherlands based on year, dimensions, all kinds of inputs, what kind of probability of a timber pile being present, timber foundation being present, depending on soil type also. So once you have then the probability of a timber pile, then you also need to know the rules for if there is a timber pile foundation and there is a certain amount of groundwater lowering, what would then be leading to this pile degradation. So how much will it degrade and how fast will it go as well? And the last bit of this model will then tell you, okay, it is degrading, over what period is it degrading, and what kind of damage is occurring from that. And then from the damage also the economic part. So how do we get from the droughts to the consequences? All that together gives then in the end an idea about the risk. Same system set up for differential settlements for shallow foundations. Again, soil type, age of the building, all the information that we have tells you about the probability of a foundation being on shallow foundations. Then once you know that there is a shallow foundation, then a lot of other things make up the risk for example, for the differential settlement. So the variability of the subsoil is an important factor there. The fact that there's basements or no basements, all kinds of additional information that we put to say something about the damage risk for the shallow foundations buildings, and of course also the subsidence rates that we have or that we expect for the future. And that together, so the map shows some input that we have from the subsidence, and then together with the other thing, again also for shallow foundations we have to know the consequences. So if there is a certain amount of deformation, what is the consequential damage category, and what will then also be the costs for that. That's the basic idea of the setup. You already see a lot of parameters. That was only the schematic approach. If you really want detail, you could read this. Don't recommend that. This is for only timber piles, all the different maps and inputs that were collected and put on top of each other. It may be a bit more easy to digest if I show it in map form. This is definitely not all the maps, but from these maps, a lot of information is extracted and combined together with the relationships, the algorithms that we have been using. This also means that a lot of you have probably contributed in one way or the other in this model somewhere, because a lot of the data in then is collected and brought together. So what is that leading to? Well, for several public websites like climate effect atlases, for example, we have made these maps which give you the risk. And the risk is not put in a number. I've shown you already how much inputs we have collected together. It's not mathematically all perfectly aligned. So there is we don't give one number, and we give these risk classes so that you get an overall view of the risk, and that you can focus our efforts in the areas where the risk is highest. So you see the risk for pile foundations and the risk for shallow foundations separately, and then from low to high. We did this for different scenarios for the groundwater, and the groundwater is driven mostly by the climate scenarios that come from KNMI. So that's the picture on the top right. For these different climate scenarios, we have the consequences in groundwater, and from the consequences in groundwater, we have the subsidence and all the rest. And these kind of maps have been published and are for policymakers. It doesn't help you as a house owner directly, but it helps policymakers to make decisions and get a bit of a better feeling of the importance of the topic. And it also shows, mainly with the droughts that we are experiencing the last few years in the Netherlands, that maybe this attention, that traditionally there has been a lot of attention to timber pile foundations and damage, that maybe we should also focus a little bit more on the shallow foundations, mainly with the climate change actually happening. So that involves different areas than we traditionally are focusing on. Total order of damages is a huge scatter at this moment. Hopefully we will be able to narrow that down in the future. Roughly 1 in 10 buildings in the Netherlands would be at risk, at a certain level of risk at this moment. Tomorrow there will be people also from KCAF present. They are collecting a lot of data from house owners, and the picture on the right shows how many people in a certain area have reported damage to their house. So that picture is not, of course, exactly the same as the pictures on the left, the original ones that we made from the model, but it gives a bit of an idea of the areas where this problem apparently is experienced. So that's what was done and reported in the papers. Also, this work is ongoing, and I think Peter already said any number or any given that you give is not good if you don't give an uncertainty bound around it. So this model by now is made fully probabilistic. We've made a sensitivity analysis of all our inputs. We had so many, so we need to figure out where to focus our attention. That's done by coupling our models to the probabilistic toolkit that was developed in Delta Ares, which is open. Yeah, you can everybody can couple their models to the toolkit, so we did that as well. And Nicoletta, who's here in the room, Nicoletta Naposi, made this probabilistic assessment so that we have a bit of an uncertainty margin at the moment, and also can find the most sensitive parameters, because there are so many of them, we need to focus our attention to the ones that are actually mattering most in the project. So with this, we can advance and say, okay, we can improve the model. There's something else that we're working on, and by request is to get from this postal code regional scale combined results to really building level. Now this is an experimental result that I'm showing you, which is not yet finished. It's not difficult to make it on a building level, but to have the uncertainty in that, if you don't know if a building is on shallow foundations or on timber piles or on concrete piles, it's useless to give any prediction on what would be the damage to subsidence. So as long as we don't know that, we should be very careful with this kind of maps. So we are making maps at the moment that for what if scenarios. What if a building is on timber piles? What if a building is on shallow foundations? And house owners very often have quite a good idea of the foundation of their house if they are in a subsidence prone area. So with that, we can also continue. Last, but certainly not least, is that the integration with new knowledge. And then Alfonso is here in the room, Alfonso Prosperi, who's working on these relationships. One of the parts of this model where there's a fragility curve between the settlement, the subsidence that's happening and the damage that is happening. So hopefully next conference, there will be an integration of that work also in this model. In summary, I talked about foundation problems, building damage due to subsidence, mainly occurring in peat and clay areas, very common in the Netherlands, I would say, because of the lowering of the groundwater and changing in amount, but also changing in location due to the climate change that is happening. We have this nationwide model. It's definitely not perfect, but at least it's a start to, at least for policymakers to start communication. And the main challenge is to get better data, mainly on foundations, but all other maps are constantly being improved as well. You can find the data for the whole country if you're interested on 2 different websites already, and hopefully being updated in the future. Thank you.
Thank you very much. Questions?
Hi, Mandy. Maybe you mentioned it. How do you model the differential settlement? What is the input you give here?
Yeah, we don't model the differential settlement, so this is mostly depending on which year we're looking at. So sometimes it's measured subsidence rate or it's modeled subsidence rate, and we make a very rough conversion from absolute settlements to differential settlements. And that's why I want to combine the work with Alfonso, and you know that what we want is in the end to get to a differential settlement in a proper way, but now it's a crude way. Yes.
Hi, thank you for the great talk. I have a question. Do you have any estimation about economic loss due to land accidents, or how to deal with that?
Sorry, can you repeat what law?
Economic loss.
Yeah, I didn't show, but we have repair costs mainly as an indicator for now for damage for the economic loss. So we're not using indirect losses, but just direct losses for if you have a certain amount of damage, you need to put a mason or a painter or something like that. And those costs we have per damage class based on a previous study. I must be honest, those dates are those costs are from 2018 at the moment, and prices are going up very quickly. So we are making new estimates in 2024, hopefully with inflation, so that will be done. It's a separate study that was done by looking at actual damaged buildings and the repair costs, and then bringing that back to the damage levels. But it needs updated, because I think if I would have shown numbers now, I would have had to increase it by at least 25%.
Anyone for just one final question? If not, let's thank Mandy for this great talk.